Hi, good afternoon. This is Dr. Islam. Today we are going to talk about this jogging. But before starting the lab, we always remind you that safety is the number one. So you look into that safety manual is there in the lab, posted in the lab wall. Today we are going to talk about that jogging. Okay, jogging is nothing but the movement of that robot. Okay, robot arm. We are going to talk about that. Robot arm is very similar to the arm we actually move. Okay, like if you want to pick up something on the right hand side, you have to go over there. Okay, if it's in the bottom, you go bottom. If it's in the up, you go up. So very similar way that the program is done. Our program is controlled by our brain, but the program is done with the microprocessor and other things. Okay, those kind of things over there. Okay, there are two modes of movement. One is called the joint mode, another one is called the world mode. Joint mode, actually that a polar coordinate system. In that case, the movement is in a circular way, so that it's that measured in terms of the degree. Okay, and that world mode is that Cartesian coordinate system. Okay, so the movement is in linear, so the movement is in terms with the millimeter. Okay, in the direction. So first time I'll talk about that joint mode, and I'll show you all those. There are 6 joints into it. Okay, so they are considered the 6 degree of freedom. Okay, so each joint there are motors, so they're called the servo motors. And I'm going to show you, this is the joint, first joint over here. Okay, so then this is J1, this is the second joint, this is J2, okay, and this is the third joint, this is J3, and this another joint over here, this is J4, and this one is J5, and this is the joint is J6. So there are 6 joints over here, so that means there are 6 freedoms, and each joint has a motor. That motor is called a servo motor. So you know how to turn it on, everything is done. This pendant, you have to look at it if there is a false sign. If there is a false sign, you use that, you hold the deadman switch and you click the reset button. Until it is gone, you keep on doing it. You keep on doing now, see that the fault one is gone. So in that case, now you have to check the mode, okay? So coordinate, okay, so coordinate, I just press this COD, so this is changing, you see then the up it is changing. I want to go to the joint mode now, okay, so it's the joint mode now. Then I'm going to say the 6 joints over there, okay. So 6 joints are also considered 6 degree of freedom, okay. So in the 6 joints, for each joint there is a servo motor, okay? So let me do this one over here. So I actually put that deadman switch, press that one, then I'm pressing the shift over there, okay? Then if I press the J1, you see that J1, because that speed is very low. So what I'm going to do, I can increase the speed over here. This over there, let's say 100%, okay? So now I press the J1, you see that? The bottom one, this one is moving, okay? You can see this one, you can see this one over here, that bottom one is moving, that is the J1, okay? Now, it just exceeded the limit, so I have to get rid of that, reset that fault, so I'm resetting it, okay? Now I'm pressing that dead pendant and the shift together, and I'm pressing that J1, okay? I'm pressing the J1, okay? And then I'm pressing J2. You see that? J2 is this one is moving, okay? So this one is moving, this is J2. Okay, then I'm pressing that J3. You see that? This 2 is moving over here. Now if you go for the J4 over there, so you can see that one is moving. You see that? This one is moving in one way. So J4 plus is moving in one way, so this counterclockwise. And you see over here, J4 minus is moving opposite way, it is that clockwise, okay? So it is in that way. Then you go for the J5, if you see this one, it is moving, in one way, okay? It's a J plus. Okay, that J5 minus, you see that is moving in the opposite way, okay? So this is then you go for that J6, You see this one over here, this is moving in one, is counterclockwise, J plus is counterclockwise, and J minus, you can see over here, it is moving in clockwise. Okay, so this is that things over there. You have to practice this thing a lot so that you will not make mistake. But one good thing is that you make the mistake, so it should be slow. If you do it, just abort it and then you go back to the other one. So when you are learning about all this, if you do many times, the things will be fine. There will be no problem. Okay. So have you understood that? In that joint mode, how to do all those things over there. There's some coordination, you have to go by the sequence, because this is that sequential type of thing, like when you write down some program, it will have to be in sequence, okay? So first one should be done, then the second one will be taken care of. Okay, they're exactly the same way it was. So you have to be careful about, you have to follow the sequence so that it should work in the right way. Now, when you press that J2, the movement of J2, it also moves that J3. Okay, so they are related. So the design in such a way that when the J2 moves in one direction, J3 moves in the opposite direction. So there will be no clash. Okay, so then I'm going to go for the J2, that is one direction. This is that you can see over here, that one is moving. So you see that when the J2 is, you are moving this one, this is the J2, at the time J3 is also moving, okay? So in that case, they make that arrangement in such a way that when J2 is moving in one direction, J3 should move in the opposite direction, so there will be no collision, okay? So now, if you go this one over here, J2 negative, you can see over here it is going in the other direction, okay? So exactly same way, if you go for that J3, you can see that J3, you can see over here, only that J3 is moving, okay? So you put that one, that plus, that's moving up, okay? So this is going in one direction only. But you see that when that J3 is moving, J2 is not moving, okay? So they are not related. So J3 is independent of J2 now, okay? So this is that J3, this is plus, and J3 minus, you see that is going down, okay? Only that one is moving, that J2 is independent of it, it's not moving any further. It is all about that, our joint mode of operation. So we can go for that one. For now, if you don't have any question, we can go for that wall mode of operation, okay? Any question, guys? Okay, so let's go for that wall mode of operation. In that wall mode, actually that is the Cartesian coordinate system. So in that case, that x plus, that is going to move in the forward direction, and x minus will be in the backward direction. The y plus will be in the left, move towards the left, y minus will move towards the right, and g plus will move up, and g minus will move down. And that measurement is done in terms with that millimeter. Okay? So, and you can change the speed of all those things over there in terms with that, the plus minus 0, okay, and plus percentage and the minus percentage, you can go all the way, or all the way 1, even the dime, it will be fine. If you keep on going down, it will be very fine. It's like very much like the tuning and the fine tuning of the radio receiver. Okay, if you want to get on a station, you tune it first, then you put the fine tuning so that you can get exact value. Okay, so the movement is very small, in that way they are controlled. Now, for the wall mode of operation, what you have to do? You have to change the coordinate, because this is the joint. Okay, so you have to go over there, and you just press this coordinate. Okay, this is that, you put that coordinate over there, and the coordinate is changed to that word. Okay, this is the word. You can see over here the word is there. That means it is fine. Now I'm going to do with the deadman switch and the shift together. Then I'm going to go for that x plus. Okay, so now it's very much in terms with that, it's called that right hand rule. So in that case, the index finger actually represents that x coordinate or x plane, and this middle finger represents that y coordinate or y plane, and that my thumb represents that z plane or z coordinate. As you can see over here, all these three are mutually perpendicular to each other. It's very much similar to that Fleming's rule in that electronics engineering. Okay, and this is the electromagnetic things. Okay, you guys already know about it. So now let's go for that x plus. Okay, when you put that x plus over there, this should move forward. You see that? It is moving forward. Okay. In that case, I can change that speed again, and you can see over here, this is x plus. You see that is moving forward. Okay. X minus moving backward. Okay. If you go for that y plus, it is moving left. Okay. If you go to y minus, it is moving right. Okay. Now, if you're going for z plus, it should go up. Okay. If you put a z minus, it should go down. Okay. So that's everything looks fine, and everything is taken care of. So you learn about the two modes of operation, and the J joint mode, and then one is the wall mode. Okay. So now, okay, this is that main thing over there, because you have to jog that your robot before you give that motion to it. Now next time, what we are going to do, we're going to make, like writing some program, we're going to make this robot to make a rectangle, make a circle, all kind of things. So that will be our next time, and we are going to find out that, this is the you go to the position. If you just click that position button, you can see the data over there. The data what we have done, J1, J4, in terms with this movement, everything data should be there. Okay, then you can take those data and can find out all those things. In terms of the speed, in terms of that, there are three different speeds over here. If you go for that up to 100, the speed over there. Now if you go down, go down over there, the speed comes down 90, 100, all kind of things over there. Go all the way to 1 is fine. And then if you go even less than 1, that is the fine. Okay, so fine. And then there's another mode, is called the V fine. Okay, that actually increase the, give the degree of rotation in case of joint, mode. And with the Cartesian mode, they actually make the speed is a millimeter. Millimeter per second, something like that. So those are the speed kind of things. You go all those things later, and we're going to do program so that we can put that combination of all those, movement of the different joints, and we can draw that, rectangle. We can draw triangles. We can draw, all kind of things over there. We can pick and, things, put and pick things with this, the joint 6. This is joint 6 over here. We can use that one to do all those things. So I think that's all for today in this lab. You guys are here. You guys can do the practice, and I'm here. I can help you in that aspect. Okay. Speed is the important thing, because the caution will have to be taken so that your speed in that normal way, or you have to start in a slow motion. Okay, and then you can increase that motion of that, speed. So there are different ways you can do it over there. So there is a button over here. This is that plus minus. You can see over there on the top. This is now the 10. Okay, so this is 10%. Okay, so the 10% of that default speed we are talking about. Now we want to increase this one, so you have to make this one go all the way. Okay, you can go all the way to 100%. So we'll do it in that 50%. That's the better way. Okay, so we'll keep it down negative. So we'll go to 50% and we'll make this one. Okay, the percentage is the speed over there. Also, there are two other speed. Okay, you can go down all the way. If you want to go down less than 1%, then what's going to happen? You see this one is going down, so that 1%. Then you have that. It's called the fine mode. Okay, in the fine mode, what you go actually, it is that you're going to make that speed incremental. Okay, it will go incremental. You have to do one time. If you have to get out of it, and then you have to press again to go to the another increment. Okay, so then if you keep on going down over there, in this one, two ways you can measure it. It is that joint is the polar coordinate. We talked about it. in terms with that they make the circular motion, so it will be in terms with that millimeter. Okay, and if you go for the Cartesian, it's a linear motion, that the movement will be in terms of that millimeter. Okay, so this is you go that B prime, also you can go over there, it will be there exactly the same way, that value is different. One is in terms with that degree, another one is in terms with that millimeter.